Greetings, distinguished members of the IEEE CSCC conference. I'm Kim, one of the authors of the paper DPP system models based on the enterprise linkage platform in electric vehicle battery industry value chain. I'm from South Korea, and I'm in the Department of Smart Factory Convergence at Sangkyukwon University. Today, I have the honor of presenting to you a detailed overview of the digital product passport, a concept that has emerged as an innovative solution for gathering and sharing product-related information throughout their life cycle. Yes, the digital product passport is a policy tool designed to greatly contribute to the circular economy. This innovative tool is a collation of data and information supplied by stakeholders within a product's value chain. The main aim of the DPP is to enhance resource efficiency within a circular economy, facilitate information-based decision-making, and promote transparency and traceability in products, materials, and components. The DPP also presents a structured collection of product-related data sets, making information accessible to a wide range of target groups such as consumers, policymakers, recyclers, and market surveillance authorities. And therefore, the preliminary design of the DPP should primarily include product-related information collected by manufacturers and thus provide the basis for more circular products. Through this, it will promote the circularity of products from the perspective of our strategies, which can be reuse, repair, refurbishment, reproduction, and recycling. Given the lack of scientific debate around on DPP around the world, our study sought to investigate design options for DPP systems and how these options could benefit stakeholders in the product value chain of the EV batteries industry. The Circularity Gap Report 2021 pointed towards an alarming increase in material use and carbon emissions. And to address these issues, the concept of the digital product passport, a tool enhancing transparency, data sharing, and standardization, has been introduced. This is part of the European Union's Green Deal and Circular Economy Action Plan, pioneering the era of product-focused policies. The DPP is aimed at providing machine-readable data on the product's origin, composition, and other pertinent details like repair and disassembly options and end-of-life handling stored on a cloud or server. This initiative is part of the EU's wider efforts to bolster our circular economy. The demand for a Europe-wide and national-wide product passport initiated by the European Resource Efficiency Platform in 2014 aims to reintegrate materials from disused products back into the production cycle, aligning with the evolution of the circular economy concept at the European level. This is particularly important as we strive towards a more sustainable future. Okay. And this slide shows the DPP system services. The Wuppertal Institute defines DPP as a dataset detailing products components, materials, repairability, and disposal methods. Product data includes manufacturing data, usage data, end-of-life data, and life cycle data. Product data, in other words, manufacturing data includes details about materials used for each component, the manufacturing process, and the physical and chemical properties of the material used, as well as their non-hazardous or hazardous effects on human health or the environment. Usage data contains documentation of replaced or repaired product parts. Next one is end-of-life data, which documents the collection, sorting, and processing of a product during its end-of-life phase. Life cycle data includes product sales data that can be used to predict the amount of waste expected at a given time and the number of resources that can be recycled. These encompass every aspect of a product's existence, from the materials used in manufacturing to the methods employed at its end-of-life phase. And such a system can be especially beneficial within the EV battery industry, which stands at the forefront of sustainable technological innovation. Okay. Next, let's delve into how DPP works. The implementation of DPP system brings unique challenges, such as maintaining data sovereignty and security. Therefore, we explains how we can approach these challenges using a software as a service, which can be named, in other words, SaaS-based architecture. First component is IIoT, the Industrial Internet of Things. In the context of data collection, the role of IIoT technologies cannot be overstated. Industrial IoT forms part of this architecture, acting as a backbone for data collection, ensuring that all information is collected and stored in real time at the manufacturing site. RFID, in other words, radio frequency identification, also plays pivotal roles in this architecture. These technologies enable the transition from just-in-time to fit-in-time production methods through comprehensive information integration. Furthermore, RFID for object identification and MQTT, recognized as a standard protocol for IoT by OSs, are central to the data collection process. This data is then standardized using the Asset Administration Shell, or AAS, and OPC UA, and then uploaded to the cloud via MQTT, ensuring interoperability and universal communication. Datification replaces human senses and is implemented in factories as well as daily life, collecting data and integrating it into actual IoT service interfaces rather than using traditional independent sensors. Multidisciplinary sensor technology enables extraction of more intelligent and high-level information, and users can instruct objects to act through arbitrary manipulation. IoT is a convergence technology that merges various technologies and constructs systems based on IoT and big data. Figure 3 in this slide shows an ecosystem model directly related to industrial applications. In terms of connectivity and criticality, IoT is more flexible, allowing for ad hoc and mobile network structures with less stringent timing and reliability requirements, except for medical applications. Conversely, industrial IoT generally employs fixed and infrastructure-based network solutions designed to meet communication and coexistence requirements. Okay, to ensure effective implementation of DPP, Digital Product Passport, data standardization is paramount. This is where the Asset Administration Shell, AAS, and OPC UA come into play. The primary industry-wide objective is to establish an Industry 4.0 platform with globally connectable AAS model by 2030. The AAS network project aims to ensure interoperability of different implementations of VMS from various companies and institutions, based on the AAS technology and verified by virtual testbeds and demonstrations. Therefore, several specific requirements based on the AAS model must be fulfilled, like connectivity and maintaining data integrity, cybersecurity, clear semantics, and incorporate AI while also setting rules for governance and data security and sovereignty. As you can see in the figure 4 in this slide, there are two types of assets set up using AAS. One is the product type, and the other is the product sector data, which is delivered to the client or Cloud AAS database using the OPC UA protocol server. To facilitate communication, the AAS uses the OPC Unified Architecture, OPC UA, and an industrial machine-to-machine communication protocol. It provides interoperability, ensuring seamless information flow from the lowest to the highest level. Open Platform Communication Unified Architecture, OPC UA, has evolved as a more flexible and accessible protocol than its predecessor, OPC Classic. It is a universal communication method used across all levels and offers multiple features for efficient communication. The classic OPC standard includes 3 software services. First one is the data access, which allows checking and retrieval of the current value of the PLC, widely used in the industrial field. It does not provide historical data. Next one is the historical data access, which can retrieve historical data. The OPC HDA server stores current data in local historian for access from the client. Last but not least, there is alarm and events, which allows registration of an alarm tag as an event on an alarm. And from here, let's talk about the DPP system model for EV batteries, which is an IT software system that helps manage data related to a product life cycle. DPP system involves interaction among various actors along a product's value chain, matching physical products to DPPs and integrating required data for DPPs. This system architecture must ensure recycling of waste back into the economy as secondary raw materials and maintain an updated product passport throughout the product life cycle. This is the reason why the trust framework architecture is necessary. It should address issues of confidential business information and intellectual property security. The DPP system model comprises the 4 service modules. First one is manufacturing data service, which covers the materials used for each product component, details of the manufacturing process, and the physical and chemical properties of the material used, including information on whether they are non-hazardous or hazardous to human health or the environment. Next one is usage data service, which includes data such as documentation of replaced or repaired products parts. Next one is end-of-life data service, which incorporates end-of-life data such as documentation of the collection, sorting, and processing of a product during its end-of-life phase. The last one is lifecycle data service, which contains data such as product sales that can be used to predict the amount of waste expected at a given time and the number of resources that can be recycled. In order to build a reliable DPP system, we employ a trust framework architecture. This includes issuers, holders, and validators of the data. The platform is discussion. The platform in discussion is a data neutral one, supporting EV battery value chain scope 1, 2, 3, and providing suppliers with solutions for real-time measured data-based life cycle assessment, which can be called LCA calculation, and product carbon footprint data exchange. Issuers in this page, issuers issue verifiable credentials to holders based on specific use cases. Typically, an issuer is a trusted party in the ecosystem that makes compliance claims for an organizations or products, and holders hold and control verifiable credentials and present them upon request. Typically, a holder is a party bound to an enterprise, entity, or individual. Validators requested presentations of verifiable credential and verify it, cryptographically verify it to ensure that the data has not been tampered with. Validators use the data to support business processes and are typically bound to organizations or individuals. This trust framework defines the basic principles, rules for participation, and technical standards to be followed in the ecosystem. Okay, well, let's go delve into discussion and challenges issue. The European Green Deal plays a significant role in our discussion as it sets new growth strategies with a focus on resource efficiency, competitive economy, and emission reduction. The European Green Deal, unveiled in 2019, aims to transform the EU into a fair and prosperous society with a resource efficient and competitive economy. One of its key strategies is managing mineral resources to decouple economic growth from resource usage. To realize this strategy, mobilizing industry for a clean and circular economy is essential. The transformation of an industrial sector and all the value chains will require around 25 years, with significant decisions and actions to be taken in the next 5 years. And in response to the rising societal and environmental challenges, the European Union is making strides in decarbonizing the transport section. The adoption of emission performance standards signifies the ecological modernization efforts of the EU. In 2019, the EU Commission President emphasized these ambitions with the announcement of the Green Deal, aiming to decarbonize the EU by 2050. The EU's climate policy report is highly ambivalent, with a heterogeneous picture emerging from the perspectives of both member states and sectors. EU-wide emissions fell by 21.6% between 1990 and 2018. The emission performance standards adopted in 2019 reflect an emphasis on the ecological modernization of the EU transport section. The German government's lack of firm commitment to the position of the German automotive industry during fleet limit negotiations enabled the comparatively ambitious EU directives. However, the EU's existing power balance and institutional configurations inhibit a more far-reaching and problematic approach to the ecological crisis in the transport sector, an aspect often not sufficiently considered in research on European environmental policy. This limitation is particularly evident in debates on environmental leadership. The Eco-Design for Sustainable Products Regulation, ESPR, which established the EU Digital Product Passport, served as a vital link between these policies. The regulation aims to broaden the scope of the Eco-Design Directive on energy-related products and sets minimum sustainability and information requirements for certain product groups. One of the most practical and significant applications of DPP is reflected in the EU's new battery regulation. The regulation addresses increasing sustainability, traceability, and social standards throughout the battery product life cycle. To implement this, a DPP system is established, comprising various service models, including manufacturing data service, usage data service, end-of-life data service, and lifecycle data service. By 2026, an electronic battery information exchange system will be set up, registering each battery model placed on the EU market and making it publicly available. This includes a battery passport, essentially a DPP for this supply chain. While the concept of digital product passport holds immense potential, it also presents numerous challenges and questions that needs to be addressed. Matters regarding data collection, updates, storage, and protection of company and business secrets require careful consideration. Moreover, the system must ensure target-oriented data management, providing relevant content to specific target groups based on the need to know principle. Despite these challenges, the DPP remains a promising tool in fostering a circular economy, contributing to resource efficiency and driving sustainable growth. Yes. Thank you for your attention to our presentation, and I look forward to one engaging discussion on the digital product passport and its immense potential. Thank you for listening.